Question 39. A project involving 9 activities is shown in the network diagram. The duration of each activity is not yet known. The following table gives the earliest start time, EST, and the latest start time, LST, for 3 of the activities. All times are in hours. Part A. What is the critical path? The float time for activity A is 2. That's the difference between the LST and the EST. Now the float time for activity C is 1. The difference between 1 and 0. Going back to our network diagram, A is not on the critical path because it has a non-zero float time. Same thing for activity C. Therefore, activity B must be on the critical path. So the critical path must be B, E, G, and I. And I've noted that here in the solution for part A. Part B. The minimum time required for this project to be completed is 19 hours. What is the duration of activity I? It's given that the minimum time required for this project is 19 hours. Now, activity I is on the critical path and must start at the 12th hour. So 19 minus 12 is equal to 7 hours, and that is the duration of activity I. Part C. The duration of activity C is 3 hours. What is the maximum amount of time that could occur between the start of activity F and the end of activity H? The project takes 19 hours from start to finish. The duration for activity I is 7 hours, and that was worked out in part B, and it's given that the duration of activity C is 3 hours. So 19 hours minus 7 hours minus 3 hours is equal to 9 hours. So there could be 9 hours from the start of activity F to the end of activity H. However, activity C has 1 hour of float time. That means activity C could start an hour later. So we have to take another hour off the 9 hours that we just worked out to give us a maximum time of 8 hours from the start of activity F to the end of activity H. And I've noted that here in the solution for part C.